Is it leather or is it pleather? It's not always easy to spot the fake. Synthetic leather, or pleather, can look and feel very much like real cowhide. It may not be the genuine article, but today, plenty of good-looking products are made from this popular material. The recipe for synthetic leather begins with a petroleum-based plasticizer dumped into a mixing tub. An ultraviolet light stabilizer is added to provide protection from the sun's rays. And then a flame retardant solution for a little fireproofing. Powdered vinyl is added until the mix reaches the consistency of pancake batter. Next, different dyes are poured into another tub, following a formula for a specific shade. The liquid vinyl mix is then piped into the tub with the coloring agents. Now a big roll of paper with a leather-like texture unwinds into the coating machine. As tinted liquid vinyl flows into the machine, a mixing arm agitates it, and rollers below apply it to the paper. The vinyl-coated paper then travels through an oven. The vinyl hardens, taking on the paper's texture. This first layer is a thin one to establish the surface grain. A second batch of vinyl will contain a thickening agent. That's why they call it the foam. It will give the fabric shape and structure. Workers pour this second vinyl concoction into the coating machine, which rolls it on top of the first layer. The double-layered vinyl then travels through another oven. The heat activates the thickening agent, causing the second layer to expand. Once the expanded vinyl is hardened, it gets a fabric backing. A machine then peels away the paper to reveal the textured first layer. Sometimes a pattern is printed onto the vinyl to make it look burnished or two-toned. Then workers mix a solution to build up the material's durability. Rollers apply it to the synthetic leather, finishing off this production run. But this pleather isn't quite ready to be shipped out. Samples from every run undergo a battery of tests. This machine rubs the fabric up to 3 million times to see how it wears. Then there's a stretch test. A weight is fastened to a strip of synthetic leather. The weight pulls the swatch to double its length, but it doesn't tear, which means this fabric has a lot of give. Next, a trial by fire. To pass this test, the fabric must self-extinguish in 2 seconds. And it does, thanks to the flame retardant that went into production. Next, a cutting is placed in a framework and heated in an oven to increase its pliability. A vacuum mold sucks the fabric to its form, proving this sample also has some thermoplastic qualities. You can't do this with real leather. With so many prints, textures, and colors now in production, this product seems to have everything covered. 10 trailers allow you to travel without reservations. Who needs a hotel if you can park the pop-up? Besides, you don't get fresh air and campfires at a hotel. 10 trailers have been around since the early part of the 20th century, and you could describe them as an overnight success. Today's 10 trailers are equipped with modern conveniences that would make anyone a happy camper. Workers begin production by welding tubular steel components together to establish a solid framework. Once it's painted, plumbed, and partially wired, wheels are bolted into place. The water storage tank goes in next. Then, aircraft-grade steel cables are strung from corner posts to a central bar. This bar is called a whiffle tree. Cranking up the whiffle tree will cause the cables to lift the corner posts, raising the trailer's roof. The trailer is wheeled to the next station, where workers lower a vinyl-covered wooden floor onto the chassis and secure it with screws. Then, they connect a cluster of wires to those already installed on the chassis to run things like kitchen appliances and stereos. The interior front wall is riveted to steel bulkheads and the trailer chassis. More wiring is threaded through the bulkheads to the trailer's side lights, and then the exterior panel is installed. Workers slide the roadside panel over the lift posts and secure it. The curbside exterior panels come in two pieces to create a space for the trailer door. Corner molding completes this assembly. Next, workers move inside and install the framework for some bench seating. They install the lower cabinetry for the kitchenette, then join it to the upper cabinet with a long metal hinge for easy pivoting. A mini fridge is inserted in the lower cabinetry, and this folding kitchenette is complete. This is the pull-out platform for one of the mattresses. It slides into channels in the exterior walls. But there's a lot more work to do before anyone can take a nap. The trailer's tent is made out of water-resistant fabric. The 5 sections are sewn separately, then zipped together at an inspection station. Inspectors scrutinize every seam for flaws. Once the tent passes inspection, it's fit onto the trailer one section at a time. Now it's time for a little roofing. The trailer's roof is made by sandwiching together many materials, and that takes a lot of industrial adhesive. The glue is rolled onto these plywood slats. These foam insulation boards also get a generous coating. Workers place the glued foam onto the roof's fiberglass outer skin. They position the wooden slats along the perimeter and add bands of metal for more reinforcement. The final layer is vinyl-coated plywood. It will be the ceiling of the trailer. A large roller compresses the glued layers together. After grooves and notches have been cut into the roof, it's wired up and 12-volt interior lights are installed in the ceiling. Trim is added to the roof's edges along with a gasket to keep it watertight. The roof's flaps are folded in a tray-like configuration and the corners are capped. Workers are now ready to raise the roof and install the tent. The assembly is inserted into grooves in the trailer ceiling using a pneumatic hammer. This tent trailer is now ready to pop up anywhere. It can accommodate a small family and is equipped to feed them outdoors or inside. It even comes with a screen door because you never know when adventure will come knocking.
Some people just can't get past that rubbery texture. But tofu enthusiasts say it's all in how you prepare it. Tofu is a great source of protein, low in saturated fat and cholesterol-free, and it's versatile, absorbing whatever flavors surround it. Tofu is made from soybeans, the seeds that grow in the pods of the soybean plant. They contain 40% protein, more than double the protein in beef or fish. They start by soaking the soybeans in cold water for 18 to 24 hours, depending on the season. In winter, beans are stored in outdoor silos and take time to warm to room temperature. Here's what the beans look like before and after soaking. As they absorb the water, they double in size and soften up a bit. The bloated soybeans go onto a conveyor belt, where a rotating device transports them to a crushing machine. The machine crushes them into a thick and grainy soup of soybean milk and pulp. It does this by forcing the beans through an internal filtering screen. Next, they transform the soup into a paste by heating it in a steam cooker for 3 to 4 minutes. Then it's into a centrifuge machine. As the chamber spins, the centrifugal force separates the milk and pulp. The milk passes through a cone-shaped filter, while the pulp, called soy meal, sticks to the sides of the chamber. The soy meal goes off to be sold for cattle and pet food. The milk stays behind to be transformed into tofu. Still piping hot, it goes into a coagulation tank to be thickened into curd. But first, they add different herbs and spices because this batch will be sold as flavored tofu. Then they add the coagulant, magnesium chloride, along with water to activate it. Then more stirring. It takes about 15 minutes for the soybean milk to congeal into soybean curd, otherwise known as tofu. When it's ready, it's still steaming, but pretty soggy. So they run it through a perforated cylinder to drain as much liquid as possible. By the time the tofu comes out the other end of the cylinder, it's relatively dry and roughly the consistency of scrambled eggs. Now it can be processed into those familiar blocks you buy at the supermarket. They transfer the tofu into large rectangular molds lined with cheesecloth. Then it's into a press that applies 130 pounds of pressure. This squeezes out most of the remaining liquid and molds the lumpy, loose tofu into a firm rectangular block measuring 15 by 29 inches. They cut the block lengthwise and widthwise into 54 blocks of 10.5 ounces each. Tofu is pretty tasteless, but like a sponge, it absorbs the flavor of whatever it comes into contact with. They drench this batch in a spicy marinade to make jalapeno-flavored tofu. After verifying the weight of each block, they package the tofu with a sprinkle of spices for garnish. Then, to kill off any bacteria, the blocks go into a pasteurizer at 230 degrees Fahrenheit for an hour. When they come out, they drop into a cooling basin filled with water just above freezing temperature. They stay submerged for about an hour. Tofu comes either pre-flavored or plain. It also comes in different textures. Firm tofu maintains its shape in soups and stir-fries, while soft tofu and soaken tofu are ideal for blended dishes and desserts. Thinking inside the box can be a good thing if you want to organize your tools. And of course, we're referring to the toolbox. Proper tool storage keeps any worksite running smoothly and efficiently. And today, you can really go big on the concept with units designed for mechanics and other pros. With a professional toolbox, you'll never have to rummage around for the tool you need. There's a place for practically everything in one of these mega tool chests. It starts with a coil of heavy-duty steel. It unwinds into a punch press that cuts the metal into panels and punches holes for later assembly. Each of these panels will be transformed into a toolbox drawer. They feed the panels into an automated bending machine. It folds them on 3 sides to create the back and sides of the drawer. It also folds over the rim. This adds strength to the drawer and gives it a smooth edge. The assembler slides the front panel onto the drawer. Then an automated welding gun reinforces the seams and secures part of the lock mechanism. To build the toolbox cabinet, a worker arranges stiffeners and lock bar grids on the back wall. Then it's over to a lineup of computerized welding guns. These guns fuse the stiffeners and grids to the panel. Each part gets numerous welds to ensure the unit really holds up. The cabinet sidewalls are next. Workers prop them up with supports as they weld the panels to the back wall. With the toolbox right side up, they install the top. They turn the cabinet around and, working from the open front, slide the lock bars into their slots. They then build the front framework and weld ledges for the drawers to the support grid. They add a panel to the bottom end of the cabinet and weld the entire perimeter. Now it's into the paint booth, where spray guns coat everything in a layer of powder paint. The paint is tough and solvent resistant, so it will hold up to oil spills in a garage environment. They install the rest of the locking mechanisms on the front of the cabinet. Then, using a guide, press the adhesive-backed logo into place. They now snap the drawer slides into holes on the cabinet's sidewalls. These slides are equipped with roller bearings that will enable the drawers to open and close smoothly. Here, they make use of the holes punched into the drawers earlier. A quick click and the drawers are fastened to the sides. The drawers come in a range of sizes to accommodate tools of different proportions. The shallow compartments will hold wrenches and screwdrivers, while the larger ones have been made for the big power tools. Workers now encase this mega tool chest in plastic and cardboard. But this job is not quite wrapped up. They tip the unit on its side and send it down the line to get wheels. The pre-packaging prevents dents and scratches along the way. A worker bolts casters on each corner of the cabinet to allow it to be easily moved around in a garage or any other worksite. Add-ons can be purchased for these tool chests, so the storage possibilities are virtually endless. That's an organizational approach you can't really mess with. Some people use them to hold hors d'oeuvres together. Kids make scale models of famous buildings and bridges out of them. And some people actually use them for their primary purpose, to remove food caught between their teeth. What are we talking about? Why, the humble toothpick, of course. Logs. Lots of birch logs are delivered to this factory. They're the raw material from which toothpicks will be made. The heavy logs are lifted by grippers and placed into a debarker. Bark isn't part of the toothpick fabrication process and is recovered by this machine. But the bark isn't thrown away. It's sold to a neighboring factory where it will be used as fuel. The debarker works in 2 steps. With 2 passes, it produces a log roll that's perfectly cylindrical and easier to mill. This log is being transported to the next processing stage. This unraveling machine unravels the log as if it were a roll of paper, cutting it with 12 fine blades, each 4/100ths of an inch thick and 2.5 inches wide. These same blades will be used later to cut toothpicks. Then, these 12 blades, positioned side by side on the unraveling machine, will form rolls of strips called billets. These tiny cutters are used to trim the ends of the toothpicks. Knives placed here and there on the machine thin the ends of the toothpicks. The roller rolls up the cut strips, forming a billet. Completed strips or billets are taken out manually. Each weighs 4 pounds. The billets are carried to the puncher. The flat toothpick puncher cuts the billet strips into small, equal-sized pieces. The cut pieces come out at this end of the machine. The punch works very rapidly. Knives come down 2,000 times per minute to cut a total of 8,000 toothpicks in just 60 seconds. Cut toothpicks fall into this chute, then into a container. At this stage, they're soft. They have to be hardened in a dryer for 4 hours at 250 degrees Fahrenheit. Then the toothpicks are transferred to the polisher. Talcum powder and friction help make the toothpicks perfectly smooth. This operation takes 4 hours. Toothpicks exit the polisher and pass through this sifter, which filters out broken ones. Those in good condition continue to an air blower system. Damaged ones are rejected. Perfect toothpicks are placed onto 2 conveyors by an air blowing system. Drums at the end of the conveyors assure quantity distribution. Then they're carried to the automatic packagers. This machine counts the toothpicks. Boxes are made up, ready for filling. The number of toothpicks included in each box matters. The packager is calibrated to place 650 toothpicks in each container, and it produces about 1,150 boxes an hour. It handles 747,500 toothpicks an hour. Some toothpicks are individually wrapped for distribution to restaurants and airlines. This machine wraps 1,200 toothpicks per minute. It automatically wraps, glues, and cuts the paper. This facility can manufacture more than 20 million toothpicks every day. And it all started from several birch logs.